Hello, my name is Masarashik, and this is my lab 1. So, for background of the lab, I made charge tape and observed its interactions with other household objects to determine its charge. And from there, I took my data and inputted them into two glowscript codes that models the tape as a point charge, and in the second code, a line of charges. So right here you have some of the math I did for the lab experiment. The tape measured to be 25 centimeters or 0.25 meters, meaning that it weighed 0.25 grams. And I did the math for f of g, which is 9.8 times 0.25 times 10 to the negative 3. And I got 2.45 newtons times 10 to and the magnitude of F electric is equal to F of G to where the tape would move. So from there, I did the calculation. KQ squared over R squared, and R squared would be 0.04 meters, is equal to 2.45 newtons. And from that, you get Q equals 6.59 times 10 to the negative 9 as the charge, because that is when the tape begins to move in our experiment. And I will use this value of Q for the first part of the code. So for part 1 of the code, you see the variables um, E 9 to the power of 10 to the 9, gravity 9.8, and then the mass, as well as the Q value I found, and the separation distance to which the tapes started to move. And from this simulation, it accurately represented what happened in the experiment. And on the right, you have the same thing, but the tape is a line of charges rather than just a point charge. And for the electric force to be slightly above or about the same as the gravitational force, I would need a Q charge of 1.19 times 10 to the negative 8 rather than the observed 6.59 times 10 to the negative 9. And these were the results. Because of the separation distance of 0.04 and a charge of 6.5 times 10 to the negative 9, the model well simulated the actual experiment of tape B moving slightly when encountered by tape A at a distance of 4 centimeters. And for part 2, with the line of charges, I will need to almost double the value of Q in order to get the same result. And this larger difference could be due to the fact that the charge model is physically different and more accurate than a point charge at the line, and the difference of Q values were also due to the fact that we assumed the charges equally distributed between tape A and tape B. And what if the signs were changed and the charge tapes would have been a negative, so whatever it attracted, it would repel. So when I rubbed the plastic pen, it had excess negative charges, therefore the charge tape and then the pen would have repelled each other rather than attract. And in terms of two negatively charged tapes, they would still repel each other because they have the same sign. And the two Q values are different because one treats the tape as a point particle while the other one treats it as a line of charges. And so the second code would be more accurate as the strip of tape has charges running throughout all of it rather than at a single point. And yes.